Are you ready? Here's the solution. Going to the top of the file, I'll add another constant. And I'll call this constant skull file. And it's going to point to the skull icon.png. This one right here. Shift enter on this cell, scroll back down, and now it's time to put all of this text that's in the Shakespeare-Hamlet.txt file from the NLTK resources into a single string. So I'll call a variable Hamlet underscore corpus and set that equal to NLTK dot corpus dot Gutenberg dot words parentheses single quotes Shakespeare hyphen Hamlet.txt. The same file name as right here. The word list is going to be equal to square brackets single quotes dot join, and I'll join the word up from my loop. So for word in Hamlet corpus will give us our list of words, and then I'll say Hamlet as string is equal to single quotes with a space dot join word list. That's our play as a string. Now all I need to do is maybe go skull underscore icon is equal to image dot open. So here we're using pillow, feed in the relative path to the file, and now it's time to create that mask. So I'll say image underscore mask is equal to a new pillow image object with mode equal to RGB, the size equal to the skull icon dot size, and the color equal to white 255, 255, 255 inside a tuple. The RGB array for this skull image will simply be a NumPy array created from the image mask. Now we can create our word cloud. Word underscore cloud is going to be equal to word cloud parentheses mask equal to the RGB array from Hamlet. I'm going to choose my background color as white, and then I'm going to pick a color map. The color map that I'm going to go for my skull image is going to be called bone. I figure that's going to be a nice combination. And for the maximum words, max underscore words argument, I'm going to pick, I'll start out with 50, and then I'm going to up it, just so you can see how a higher number will actually look a lot better. Then I'll use wordCloud.generate to generate my image, but of course I have to feed in which string I want to use. So Hamlet as string. That's it for the word cloud. Now it's all going to be matplotlib. plt.figure sets the size of our figure. I'm going to go again with 16 and 8. I think that's a good size for me and for the video. I'll use the IamShow method, feed in the word cloud, along with an interpolation of bilinear. So I think that's spelled right. Good. I'll remove the axes. So axis parentheses off. And then I'll show my chart. The moment of truth, of course, is hitting Shift Enter on this. Let's see what it looks like. All right, so I've got a value error. Canvas size is too small. Any idea what went wrong? The reason is I've got an entirely white canvas. The RGB array is fully white. There's no place for the word cloud to draw anything. And that's because I haven't called imagemask.paste with the skull icon. So I'll need to write image_mask.paste parentheses skull icon, comma, box equals skull icon. And if I refresh my cell now, then this error should disappear. So here's my image, and nobody in the world will be able to tell that this is indeed a skull image. The culprit this time is the maximum number of words. This number here is too small. It doesn't actually help us see any of the detail in the image. So I'm going to change it from 50 to 600 and refresh my cell. For this many words, your computer might actually run for a little while because it's doing a lot of work to generate this image. But I think the wait was worth it. We've got a beautiful word cloud here with a fantastic color scheme and a lot of the details in the word cloud being made visible by the high number of words in the word cloud. Now that we're done with the two practice word clouds and using the NLTK resources, it's time to create a word cloud for our ham and our spam messages. Those we will create from our dataset, and I'll see you in the next lesson. Take care.